Right. Today we're going to solve radical equations. Remember, radical is not the 80s word for cool. It is just another way of saying a root, square root. So this is what we mean by radical. And it's important to talk about the definition of what this actually means. If we have just a square root symbol, it's assumed that there's a little 2 inside of it. We could also have any other number inside of it. We talked about the definition, what that means, but what I want to go back to for today is what does this mean as an exponent? So the square root of a number, square root of x, is x to the 1/2 power. And it just means that we're looking for a number that multiplies, times itself, to equal what we have under it. But in today's lesson, you're not really going to need to know that. So we're going to solve things today like the square root of x equals 3. So remembering that this is really x to the 1/2, equals 3. We want to raise this to the 1 power so that we just have x equals a number. And we can do that. We know that 1/2 times 2 equals 1. So we want to do 3 to the 2 as well. So this is x equals 1. So this is kind of a fancy way of looking at this. The opposite of square root is squaring. So we're going to square both sides. There's a shorter way of saying that. Okay. Now, there's a couple kind of key features here. If we have more than one thing under the square root, that's totally fine. X minus 2 equals, say, 4. So again, we're going to just square both sides. And we have the entire square root canceling, leaving x minus 2. 4 squared would be 16. And then we just solve this as we would any other problem in algebra by adding, multiplying, subtracting, dividing, the same thing from both sides. So we get x equals 18. Now there's a trick with these that's a little bit different maybe than what you've seen. You want to treat radicals kind of like you treated parentheses when you've solved equations so far. So if I had something like this, the square root of x plus 2, and then out here minus 3. Equals 5. I have to get rid of this minus 3 before I can square both sides. Because if I squared this now, what I would actually have is the square root of x plus 2 minus 3 times the square root of x plus 2 minus 3, which we'd have a FOIL going on here, right? We'd have a just double distributive property. We'd actually end up with this times this, but we'd also have this times this, and then we'd have this times this, and this times this. So we'd have a lot of terms going on. No. Okay. So instead, what we're going to do, you could actually do that, but it's not going to be very helpful. It's going to be much easier if you just add 3 to both sides first. So we're actually isolating our square root before we isolate our variable. Then, once our square root is isolated, we can square both sides. So I'm going to just write it like this. X plus 2 equals 64, so x would equal 62. So the key step here is if you don't have your square root already isolated, to isolate that and then square. And there's another way you might see that, which is if we had, try to write a little thicker. If I had like 3 square roots of x plus 1 equals 27. So remember that this just means 3 times the square root of x plus 1. And since we want to isolate our square root, we're going to first divide by 3, which would give us the square root of x plus 1. Which means x plus 1 equals 81, and x equals 8. And you might see problems that have both of those things going on. So what if I had 2 square roots? I'm going to actually make this even a little more complicated. Of 4x minus 1. So notice now I have a coefficient here. And then I'm going to add something here, plus 3, equals, so let's just look at this side before I even know what it equals. I almost think of this whole thing as a variable. So when I see this, I'm kind of in my head, I'm seeing like 2y plus 3. But instead of y, I just know it's this chunk of stuff. Because I want to isolate my whole square root. And in order to do that, I'm going to have to subtract the 3. And then I'm going to have to divide by 2. You guys see what I mean? Okay. And let's make this equal to 7. So I'm going to do what I just said. I want to isolate my entire square root here. So I'm going to subtract 3 from both sides. And I have 2 square roots of 4x minus 1 equal to 14. Then I'm going to divide by 2. So now I have the square root of 4x minus 1 equals 7. Now I'm going to square both sides. 4x minus 1 equals 49. Add 1 to both sides. 4x equals 50. And then we're going to divide by 4. So to make sure I'm still on the thing here. So x equals 25 halves, which is a fraction.
12.5.
12.5. Yeah. However you want to look at that number. And that's pretty much as complicated as they're going to get for now. Just one other kind of quick reminder. If you had something like this, the negative square root of, let's say, 2x plus 3 and then minus 1 equals negative 11. So first I'm going to add 1. I have the negative square root of 2x plus 3 equals, what is negative 11 plus 1? Negative 10. Then I'm going to take the negative of both sides. I'm going to multiply by negative 1. So I have the square root of 2x plus 3 equals 10. Then I'm going to square both sides. 2x plus 3 equals 100. 2x equals 97. So x equals 97 halves. Really nice, beautiful number. 97 halves. My favorite number. One of them anyway. Of a lot of them. So negative just means like -1 times this. So we just divide by -1 or multiply by -1 to get rid of that. That's it. Any questions?